Okay, all right. So today what we're going to do is this. I want to finish the analyzing a function from a graph, meaning whether it's a function or not from a graph, because if you remember, we still have three questions at the end. So we'll do that, and then I want to show you more regions questions on domain and range. And it's not much of a lesson. It's more like I just have some questions to go over with you. Okay? All right. So with that said, let's go. Okay, all right. So this is where we left off last time. So what we're going to do is I'm just gonna go over the last three questions with you and then show you what domain and range questions look like on the regions. Okay, all right. So this is the first one I'd like you guys to look at. Let me see if I could expand this. So here it says, which relation does not represent a function, right? So again, relation is just a umbrella term for the relationship between any two sets of data, so to speak. Okay, all right, so that's not, so which one is not a function? Well, the x, look at the choice one, right? 1, 2, 3, 4, 5, 6, nothing repeats, so not it's a function, all right? This next one, right, it passes the vertical line test, so that's a function, right? This is a square root, right? So square root functions are functions. Okay, so that started out. This one is like as anti-function as it gets, because look, like 1, 4, 1, 5, 2, 6, 2, 7, 3, 8, 3, 9. I mean, look how many times these numbers repeated, right? So that's it, all right? That's not a function, okay? All right, next question. Marcel claims that the graph below represents a function. State whether Marcel is correct. So is he correct? No, right? Because if we were to take, so I can show it to you in a couple of ways, right? I could go with the vertical line test like this. Now everything's good so far, but watch, look right here, right? The vertical line here touches 2 points. That's not good. The other way you can prove it is by saying that when x is 2, f of x or y is either -1, right? Because this point is 2, -1, and this one is 2, 3, right? It's both, not either actually. It's both 2, 3, and 2, -1, right? So it repeats, right? And then you can state, remember that statement that we had, right, from what feels like some time ago, right? Each element of the range has to be paired with exactly one element of the domain, right? Again, each element of the range is paired with exactly one element of the domain. So that's the language you can use to explain that too, okay? Or you can say, the x repeated twice, I would use the former, all right? It's more official language. Okay, all right, now let's see. What is this? Nora says that the graph of a circle is a function. Okay, so this is what Nora is saying. So let me draw a circle, right? Nora said the graph of a function because she could trace the whole graph without picking up her whole pencil. So this is what Nora is trying to say. Nora is trying to say, hey, look, I could, without picking up my pencil, I could go and just draw a circle. Okay, Mia, so this is Nora, Mia says the circle is not a function because multiple values of x maps to the same y value. All right, so think about this one. I'm gonna let you think about this one. Okay, so press pause right now. All right, what do you think? Who's right and who's wrong? All right, let's analyze this. So Nora is definitely wrong, right? So Nora is wrong because a function has to pass the vertical line test. Function has to pass vertical line test, right? Now, what do you think what Mia said? Was Mia right? That is not a function, right? Now, Mia is right in the fact that it's not a function, but look at her explanation, okay? Multiple values of x map to the same y values. Now, perfect example here. Look at the multiple choice question we did 2 questions ago, right? This was not a function. Now, does this table, this map, match this statement? Multiple values of x map to the same y value. It's not true, right? Look, because what Mia is saying is, if, I'll give you an example, right? I'm just recreating this table except with different arrows. So watch this. What if, what Nora is saying, what Mia is saying is this. She's saying this, that if you see this, right, then that makes this not a function. That's not true, that's a function, because nothing repeated. Here, the 1 repeated twice, right? 2 repeated twice, 3 repeated twice. But look, this is, if I were to write this out, this is 1, 4, right? 2, 4, right? And let's say 3, 7, right? Nothing repeated. Okay, so the statement here, the statement is actually wrong. Yes, it's true, it's not a function, right? But the reason she gave was wrong. It's the opposite, right? Because it's not a function because multiple values of y map to the same x value. Okay, meaning, right, if you put x into the machine, you get several instances of different y's, and that's not good. So that's the reason. Okay, so let me read you the official answer. Okay, because I know you guys are thinking that. So I'll read this to you. Okay, right? So I'll read it. So Nora's reason is wrong since a circle is not a function because it fails the vertical line test. Okay, that's the obvious one, right? Mia is wrong since a circle is not a function because multiple values of y map to the same x value. So it's the opposite of that statement, actually. Hold on, let me get the lights. Okay, all right, let's move on. Okay, all right. Now, today we're gonna spend a little bit more time on domain and range. Okay, so the only way that I could show you this is just simply by showing you some questions from the regions, because you're actually still evaluating functions, believe it or not. Okay, all right, so now I'll give you one example and then I'll let you do the rest. How about that? Okay, all right, so let's see. So here it says if the function f of x equals to x squared, so y equals x squared, right? Same thing, right? Has the domain 0, 1, 4, 9. What's the range? So now what's domain again? Right, the x value. So if you put in 0 into the function machine, 1 into the machine, 4 into the machine, 9 into the machine, what can possibly happen? That's all. Okay, so watch this. All right, I'm just gonna like plug it in. So when x is 0, right? So f of 0, right? I'm just replacing x with the number 0, right? It's 0 squared. What's 0 squared? 0. Okay, so what's when f? It's f of 1, right? When x is 1, 1 squared is 1. F of 4, that's 4 squared, that's 16. And then what's f of 9? 9 squared, that's 81. So which one of these choices has these 4 numbers? Okay, 0, 1, 16, 81, that's it. Okay, that's it, yeah, all right. So with that said, why don't you guys try, so let's call that number 1, right? So I'll call these 2, 3, 4, and 5. Okay, so yeah, that's it. That's all it is. All you're doing is substituting / evaluating expressions, and you know, in the 8th grade we call it evaluating functions. Okay, so press pause right now. All right, it might be very early in the morning, or like I've had to do the last two like in my head over and over. All right, so two is straightforward, right? You just plug it in. Three, the lesson that you should learn from three is if you have to look for a domain, you don't have to repeat the value. So what do I mean? Like you see that 0, 1, 1, 4, 4, you only have to state that once. You don't have to write 0, 1, 1, 4, 4 in the what solution set, so to speak. Okay, this one, I was scratching my head for the longest because negative 16 showed up twice, and then I keep thinking I'm making a mistake. But sometimes it happens. Sometimes you have functions where you go from negative 2 to negative 1, and the range will be negative 16 and negative 16. It happens, okay? Because the graph looks very funky, okay? So let's see. Yep, all right. What do I have to add about that? Nothing, okay? So number 5, right? Fairly straightforward, but I have to keep looking over and over, okay? Oh, by the way, so the word inclusive here, right? The word inclusive here, it means that you have to use negative 2, 1, 0, and 1. If it's exclusive for both of them, that means you don't use negative 2. So you wouldn't put this, you would only put negative 1 and 0, and you wouldn't put in 1. All right, understand that, right? Inclusive means, hey, put negative 2 and also 1 in, okay? Same thing here, right? You see that the line underneath this, right? It's trying to say the same thing. It's saying, right, this little line here, right? It's saying, hey, include that. Include 2 and include 6 also. So that's what they're trying to say, okay? Now let me see if there are more questions. Oh, that's it. Oh, nice. Okay, cool. All right, so that's what we're done here. Tomorrow, I'm going to show you how to define appropriate domain and range, and those are all word problems, but there's really not much to solve, okay? So that should be pretty good. Okay, that's it. Not bad, all right? Under 12 minutes. Thanks for watching. Have a good day, and I will talk to you guys on the next episode. Bye-bye. OMG, that was so good.